Okay, so this is our second video where we're going to now look at the actual sketching of the polynomial, which will involve us using all the stuff that we covered today with coefficient test, graph, and behavior finding roots. So being able to make the sketch of the graph really is a nice comprehensive question that allows you to really see if you understood all the key concepts. Because if you mess up on one, then your sketch isn't going to come out. So we're going to start with looking at number 88. So this is going to be 3x squared. I'm sorry, 3x cubed minus 24. Minus 24. All right, so first, I want to write out, well, what is the degree? Well, this is a third degree polynomial. Okay, the highest power is 3. The lead coefficient is positive. The positive. So, odd degree lead coefficient. So that means my end behavior is going to look something like, I don't know what's happening in the middle, but I know it's kind of start to look like this. So go to the left, it goes down, go to the right. Now I want to start figuring out some more particulars. What's happening in the middle? So that's where now we're going to get into solving or finding the zeros for the polynomial. So I start by making my polynomial equal to 0, and I'm going to try to factor. So in this case here, I start with looking for greatest common factor. I can see that there's a 3x squared that is a greatest common factor. So that's going to leave me with x minus. So now I have my roots. So what are my roots? 0, 8. But the 0 root is appearing twice. Okay? So this is a multiplicity of 2. 8 is only showing up one as a power 1. The coefficient, don't get confused and think, well, but that's a root 2, right? Mr. Sardui, isn't 3 a root? No, it's not. 3 is not going to be 0. It's what values of x. So again, zeros, put that over here. So again, 0 are what values of x. That's the important term. Values of x. Not the number. Values of x make polynomial. Don't get lured in or suckered into like taking 3 and things. All right, so now let's construct our sketch. All right, so we said it's an odd degree, positive lead coefficient, so it's going to be here and then up here. And now we have our roots, so 0, make this 8 over here. So again, this is just a sketch. It doesn't have to be totally perfect. Now, how are we going to weave through these points? So the 0 has a multiplicity of 2. So that means we're going to go up 2, but not cross. Remember, when it's an even multiplicity, we bounce off the root, or we are tangent. I'm going to say the word tangent because that's our word. We are tangent to the root. And then when we have an odd multiplicity, we're going to go through the root. So that's what my sketch would look like for this. And again, I'd like to just label it sketch because I don't want people to think, oh, I made the graph, right? No, you made a sketch of the graph. And you, again, the important key features that get looked at are going to be, do you have the roots? Is it behaving the way it's supposed to be behaving through the root? Is the end behavior correct? Those are the things that get looked at, not how accurate this curve is. Maybe it's like it really takes a while for it to like make a turn, or maybe it does it like pretty direct and fast. This maybe it goes further down. I don't know. I'd have to plot points to do that, but we're not asked to do that. We're just asked to make the general sketch of what's going on. All right, so number 88, that's where you see you have, excuse me, you have multiple things that you're going to do. So applying the lead coefficient test, we did. Finding the zeros of the polynomial, we did. Plotting sufficient solution points. So that was us finding the roots, and we plotted those. So remember that word solution is another way of saying the root, the zeros. And then plotting a continuous curve. So we did all the things that we needed for number 8. All right, let's go ahead and we'll look at another one. I'm going to push this off to the side, and let's go ahead and let's grab a different one. This time I'm going to look at number 91. All right, so 91, we have x cubed plus 3x squared minus 9x minus 27. So let's start with some easy things. So what's the degree? So this is in non-factored form, so it makes it easy for me to read the degree. Lead, the highest power is 3. What's the lead coefficient? It's a positive 1, so that's positive. So already I know starting, go to the left, it's down, then go to the right, up. Another question is, well, what's happening in the middle? We gotta. So next, we gotta find the zeros. All right, so that means that polynomial equal to 0 solve. So unlike the last example, there is no greatest common factor. Okay, but you saw in the previous video, a way that I could try to factor is by grouping. So I'm going to make my two groups, kind of highlighting here. These are my two groups. And okay, in the first group, I can factor out squared. So that leaves me with plus 3. So now when I go into the second group, I'm looking to try to factor something out to make it look like x plus 3. And yeah, I can do that. That's going to give me x3. I factor out as a 9. Now the two groups have something in common. It's x plus 3. Factor that out. That leaves me with x squared minus 9. And then we're going to factor this. This is the difference of squares. This is going to be plus 3 first. So if I'm writing out the roots, the zeros, it's negative 3 and positive 3. But the negative 3, notice, appears twice. So we're going to say this has a multiplicity. The 3 is only showing up one time. So now so here I'm going to plot my roots. So it was just negative 3, 3. So my graph, we said from the lead coefficient test, I'm going to start down here, end up. Okay. Now what happens in the middle? A negative 3, it has a multiplicity of 2. So that's an even multiplicity. So I'm going to get up to 3, and I'm going to be tangent there. So that's why I'm bouncing off. And then 3, we're going to go through 3 because it was an odd multiplicity. So bounce, there it is, and then the cross. So this, yeah. All right. So as you can see in these two examples, let me get out here. So you can see in these two examples, we're really touching upon everything that we discussed today. The zeros, the end behavior, looking at the characteristics of the polynomial, always smooth, continuous curves, not, sharp turns. So to make this sketch incorrectly, so let me just kind of go back. You should not be doing this. You should not be doing something like this. That is not a polynomial because you're making these sharp turns. This should be a nice curve the turn. This should be curved, not straight lines. Okay, so always smooth, continuous curves. That's important too. Okay, don't just play connect the dots and drawing straight lines all over the place. That's not how it works. Same thing goes for whenever you draw quadratic. Some people, they plot the points and then it just turns into like, elementary school connect the dots. That's not how it looks. You need to draw smooth transitional curves. Okay, so if you're doing that, make sure you correct that behavior so that way you don't get points docked off when it comes time to do assessment. All right, so that does it for this video. Again, if you have any questions, please feel free to email me, let me know, and I'll be more than happy to do more.